Okay, on 23, they want us to do this one by the quadratic formula. So you have to show enough work, you must show enough work so I can tell that you did the procedure that was asked for. So this one is the quadratic formula. The quadratic formula is negative b, so you have to know, plus or minus b squared minus 4ac, all divided by 2a. So that's the formula that gives you the two zeros without completing the square, without factoring, I think it's the fastest one. Okay, so 23. Here's my scratch paper for 23. Okay, same start though. We got to get all of this stuff on the other side. So I'll add 3 to this side and add 6x to this side. So we have 3x, this is 23. So I've got 3x squared. We've got a positive 6x over there, and then a negative 8 plus 3, so minus 5 equals 0. Okay, 3 is A, 6 is B, negative 5 is C. So it's negative B plus or minus B squared minus 4AC divided by 2A. So it's the negative B number, so it's negative and then a 6, so negative 6 plus or minus b squared, so 6 squared is 36, minus 4 times the a number, which is 3, times the c number, which is negative 5. All divided by 2 times the a number. 2 times 3 is 6. So inside here, this piece in here is called the discriminant. We have to know that for later. You can already tell. If the square root becomes positive, okay, if that's a positive answer, well then there's 2 solutions. If the square root is 0, then there's 1 solution, and if the square root is negative, well then they're imaginary, so there's no solutions. Okay, well negative 5, you can use your calculator for it all at once. You can type it in exactly like that. It's negative 4 times negative 5, so that's going to be positive. I could probably do this in my head if I wanted to. 4 times 5 is 20, times 3 is 60, so it's 36 plus 60. Or I could do 36 on the calculator minus 4 times 3 times negative 5. You can type it just straight up and get the 96 with the calculator also. So I have negative 6 plus or minus the square root of 96 over 6. Okay, see the square root of 96 is going to have 2 solutions. So let's go ahead and see what that is. So I'm going to do negative 6 plus root 96 divided by 6. That's going to be one of the answers. And I'm going to do negative 6 minus root 96 divided by 6. That will be the other answer. Okay, so let's see what that is. 6 plus the square root of 96. Now you got to hit enter here so that you get the answer to the top, then divide it by 6. So 9.8. Oops, that's not right. Let me try that again. It's negative 6 plus. I didn't type that in right. Negative 6 plus the square root of 96. So the top part is 3.79 divided by 6. So 0.63. Then I need negative 6 minus the square root of 96. Divide that by 6. Negative 263. Okay, those are the 2 zeros. Okay, so the zeros that I have is, what were they? 0.63 over up 0 and negative 2.63 up 0. So right about there, 0.63 and negative 2.63, right about there. Okay, I'll come up with the vertex next. The vertex is just this part of the quadratic formula. So the vertex is negative b over 2a, and then stick that in. Okay, so that's going to be negative 6 over 2 times 3, so 6. So the vertex starts at negative 1. The vertex is always halfway between these two. If we would have added these two, we could have just done it by the average also. If I did 63 plus negative 2, 63 cut in half. Well, that makes negative 2 cut in half. See, that's also negative 1. So the vertex is always halfway between the zeros. So it's going to be sideways negative 1. Then you take that and plug it back in the original. So I'm going to take this negative 1 and plug it back in the original to see what y is. So that will be 3 times negative 1 squared for this piece, plus 6 times negative 1 for that piece, minus 5. That will be the y. So that's 3 times 1 is 3. 6 times negative 1 is negative 6 minus 5. So we have 3 minus 11, so negative 8. So there's the vertex, negative 1, negative 8. Okay, so I'll graph that. Negative 1, negative 8 is right there. Okay, when we have it in AX, when we have it in ABC form, that first A number right there is the y multiplier. The y's are going to be multiplied times 3, because what we would have ended up doing, here's again just y, we would have set that equal to y, and eventually we would have divided off that 3 over there. So the y would have been 1/3, so the inverse of 1/3 on the y's is times 3. So the y multiplier is always the A number over here. So the y's are all multiplied by 3. So instead of going over 1 up 1, I'm going to go over 1 up 3. So from the vertex, I'm going to go over 1 up 3. Over 1 up 3. Okay, well, here's the vertex. If I go over 1, that'll be 0. If I go over 1 the other way, it'll be at negative 2. And then up 3 from here, if I start at negative 8 and go up 3, I'm at negative 5 and negative 5, which happens to be those two dots. So that one I could get all of the dots graphed. Okay, so try 24. Do it by quadratic formula. All right, put the negative 11x over there. Minus 4x, I'll do plus 4x squared over there. And minus 6, so I'll do a plus 6 over there. All that has to get onto the other side, so this side is equal to 0. Okay, so 4x squared minus x squared, so I've got 3x squared. Negative 11 plus 9 would be minus 2x, and 6 minus 5 will be plus 1 equals 0. So there's my A, there's the B, and there's the C. So negative b plus or minus the square root of b squared minus 4ac divided by 2a. So I need the negative of negative 2, so that'll make it positive 2, plus or minus. Negative 2 squared is positive 4, minus 4 times the a number is 3, times the c number is 1, all divided by 2 times 3. So that bottom number will be 6. Now take a look at this. This is 4 minus 12. I already know there's going to be no solutions because the discriminant is negative. It's going to end up being 2 plus or minus 4 minus 12 is negative 8. Oops, that should have been a 3. Doesn't really matter because it's going to be imaginary. 2 times 3 is 6. See, it's imaginary right there. It's 2 plus or minus an imaginary square root of 8 over 6. That I means there's no zeros. It means it's not going to touch. It's either going to look like that and not touch, or like that and not touch. No zeros. So 24 have no zeros. The vertex. Negative b over 2a, the front part of the quadratic formula, gives me the x part of the vertex. So that's going to be negative b, so negative negative 2 over 2 times 3. So the vertex starts at 1/3. Now I need to stick 1/3 in there. I'm just going to have my machine do that. So I'm going to go 3 times 1/3 squared. minus 2 times 1/3 plus 1, and see what it is. 2/3. So, and I got 1/3 as the x part, stick 1/3 in and it gives you the y part. So this vertex is at 1/3, 2/3. All right, so if I go over 1 from there, if I add 1 to 1/3, it'd be 1 and 1/3. If I subtract 1 from 1/3, it'd be negative 2/3. So that's to the right one and to the left one. And number 24 has a y multiplier of 3. Okay, so instead of going over 1, up 1, so 1/3, 2/3, by the way, is right about there. So there's the vertex. Okay, I want to go over 1 and then up 3. So over 1, up 1, 2, 3, it's right in there. And over 1, up 1, 2, 3, right in there. So if I go up 3 from this one, it puts it at 3 and 2/3. And there's the graph. Okay, so here's the determinant. It's just that inside part. It's the b squared minus 4ac part. See, if that ends up being a positive number like the square root of 5, well then you have the positive square root of 5 and you have the negative square root of 5. There's 2 answers. So if whatever this is positive, there's 2 answers. So the square root of a positive number, there's 2 solutions. 2 zeros. But if it's the square root of 0, the square root of 0 is actually 0. It has exactly 1 answer. So if we have the square root of 0, it would be the other part of it. It would be the negative b over 2a plus part, because this part then becomes 0. So it only has 1 answer. That, basically it's the vertex. So if it's got, if the square root part of the discriminant is 0, then there's 1 solution. It doesn't have a plus and minus anymore because the square root of 0 is just 0. And then, of course, if you have the square root of negative 4, well, that becomes positive 2i and negative 2i. So those are imaginary, so there's 0 answers there. There's no zeros. So you can tell how many zeros you have just by looking at the square root part. Okay, so let's take a look at this. I'll add the 9m over there. So really we have negative 4m squared plus 3m minus 5 equals 0. Okay, the discriminant. B squared, that's 3 squared, that's 9, minus 4 times a times c. Well, that's 3 negatives, and that's a big number. 9 minus whatever 16 times, 9 minus 80. Whatever that is, I don't even care what it is, but I do know it's negative. This one has no zeros. I don't even have to go any further because I know there are none. The square root part became negative. What about 26? I'll move the 4n over there. That's really 8n squared. So this would be a plus 4n. Oh no, it'll be another minus 4n. So that makes negative 8n plus 2. Okay, to the discriminant. B squared, negative 8 times negative 8 is positive 64, minus 4 times a, which is 8, times 4ac, which is 2. So that's 64 minus 64. That ends up being the square root of 0. There's 1 0 here. There's 1 answer when the discriminant becomes 0. (27), I'll add the 8 over here. So we have negative 6k squared minus 7k minus 2. Okay, so we got the square root of negative 7 times negative 7 is 49, minus 4 times a, which is negative 6, times c, which is negative 2. Okay, that's going to be close. 3 negatives makes it negative, so it's going to be the square root of 49 minus, that's 24 times 2. That's the square root of 1, that's positive, 2 zeros. This has 2 answers. It's going to cross the x-axis twice. That's what that means. This one up here is going to touch the x-axis once, only once. This one over here never touches the x-axis. So we can get an idea of what the graph is going to look like. Okay, I'll add the 10r from here, and I'll subtract the 6 from there. So really that's 8r squared plus 8r minus, or plus 2. Now it's almost the same as that one up there. Okay, b squared, that's 64. Minus 4 times a, which is 8, times c, which is 2. Doesn't look like that's going to change anything, does it? That's 64 minus all of that. So see, the a and the c terms were the same thing, so that still becomes the square root of 0. One solution, 1, 0. Touches the graph one time. Here, I'll move the 10 over. So this one's really 2v squared minus 4v plus 2. b squared, negative 4 squared is positive 16 minus 4 times a times c. 4 times 2 is 8, times 2 is 16. This is 16 minus 16. Ends up being the square root of 0. That means it's going to touch one time like that. So there is 1, 0. Let's see, I'll subtract the 2p squared over here, and then I'll also subtract the 5p over there. So I got negative 6p squared minus 5p equals 0. Okay, the negative 6 is a, the negative 5 is b, and then there's a plus 0. The c is equal to 0 in this case because it's missing. Not that 0, the 0 that would have been after the p. I could have written that as negative 6p squared minus 5p plus 0 equals 0, a, b, c. Okay, b squared, negative 5 squared is 25, minus 4 times a, which is negative 6, times c, which is 0. Well, that's, anything times 0 is 0, so that just becomes 25 minus 0. It's the square root of 25. That's positive. It'll have 2 answers. In fact, we know what they are. One's 5 and one's negative 5. There's 2 zeros. Okay, now let's put these in our calculator, use the zoom function, and what do we have to do? Find the vertex and the zeros. Okay. So let's have our calculator do that. So on these kind, there should be no work. It's just answers because we're just having our machine do the entire thing. Okay, so let's wake up the machine here. So type it in first. Y equals. I got 44x squared minus 325x plus 9. Now I'm going to do zoom number 6 because that will get it onto the 10 by 10 by 10 grid, kind of like these little pictures. It'll put the calculator to a 10 by 10 by 10 grid. So I'm going to go zoom number 6. Okay, so that's the whole point of these. It's not fitting on there very nice. So now I'm going to have to zoom out. Obviously, it needs to be wider. It's only showing one little piece of the parabola. It needs to be wider, probably needs to be taller. So that's what the window is for. I need to make the window bigger. See, the window, the x, the sideways, is only going from negative 10 to 10. So I'm going to make it go to maybe negative, I like to go all the way out to 100. Let's go negative 100 to positive 100. Now, I don't want 100 tick marks. That's what that scale is. It'll put a tick mark every one spot. I'll make a tick mark every 10 spots. And then I like to keep the window square, so I'm going to make it go up and down 100 also by tens. That's just going to make the sideways 10, this sideways 10, sideways 100, up and down 100, count by tens. Basically, it's zooming out. Okay, so as you can see, it's still just got part of the parabola. I still need to go wider, so that didn't get wide enough. I still can't see my whole picture. So I think I'll just add another 0. Go out to 1,000, and then count by hundreds. Just searching for it. Go out to 1,000, out to 1,000, count by hundreds. So now sideways is going from negative 1,000 to positive 1,000, and up and down 1,000 to positive, negative positive 1,000. Okay, that might have been too far. Now it's probably so right in. Okay, I'm having a hard time finding this very first one. How about negative 500? By hundreds to negative 500 to 500 by 100. Let's try that. Okay, what has happened here? Let me go back to 100. Why is this one giving me so much trouble? Okay, so there it is. Still don't quite have it. Let me make sure I typed it all in right. Okay, well, how about I'll go out to 200. I'll count by hundreds. See, now this is 100, 200. You know, maybe it's coming down and coming right back up really tight there. It might be too wide. I'm just going to go to 50. Now the x is negative 50 to... Okay, see what happened? Yeah, it was too wide. It's coming back up already, right there. It's right on the x-axis. So I was too wide from that. How about I just go out to maybe negative 30 to positive 30 and count that one by tens. So it's going sideways 30, it's going up and down to 200. There it is. It's just really deep. So see, 200's not quite enough to see how far down it goes. So maybe I'll go down a little bit more to maybe negative 500. So it's going to look sideways 30, up and down to 500. Okay, there it is. See, right there's 1 and 0, right there's another 0, and the vertex is right there someplace. Okay, so let's ask our calculator for this one. Now remember, I counted by tens. If I hit the window again, see, I counted by tens. So every one of these tick marks is a 10. That's negative 10, negative 20, negative 30, 10, 20, 30. So I'm going to go second, calculate a 0. Now see, right there's the little bug. I want that one. I can see where it is. So it tells me to go to the left of that. Well, I'm going to type in negative 10 because negative 10 is right there. That's definitely to the left of that, where that picture is. Now it wants me to type in something to the right. I'm not going to put in positive 10 because that's too far. That's including this one. I need it to be more right, like right in here. So if that's 10, I'm going to say 2. I just need to be to the right of it. And see, it's going to search between here for the thing that crosses at 0. So it should find it. As long as the picture is between these two numbers, it'll find it. So I don't have to guess. I'm just going to push enter. So there's that one. It's at 0.030. So there's one of the zeros. Now I'm going to find this one. Same thing. Go to second, calculate. So second, calculate the other 0. Now I have to be to the left of this one. So I got to scoot over a little bit. So now I'll start looking at about 5. See, that put the little marker right there. And now it needs to be to the right of this one, someplace out here, maybe 12. So see, it's going to look between these two spots and find that 0 in between, so I don't need to guess, just hit enter. There's the other one, 7.4. Now that's as close as it could get. See, that's negative 1 times 10 to the negative 10. That's 0.0000. That's 10 zeros. It's rounding as close as it can get to 0. So we have 7.4, negative 7, or positive 7.40. There's the two zeros. The vertex is right there. Okay, that's also under calculate. Second, calculate. Now it doesn't say vertex, but we know that that was the smallest spot on the graph, so it's called the minimum. The graph was looking like this. The vertex was the smallest, the lowest spot. So we want to do number 3, minimum. And now it's going to do the same thing. You got to be to the left of where that minimum is. So I'll just type in something like -1. Someplace to the left. It's obviously to the left there. Then maybe something out here, 10. That's obviously to the right. It's going to search between here and find the minimum smallest value. Hit enter, and here comes the minimum value, 3.7, and it's down 591.1. So there's the vertex, 3.7, negative 591.1. Okay, 32. So type it in, negative 4x squared minus 25x minus 39. Okay, the zoom is all messed up from the last problem, so I'm going to hit zoom number 6 again. That's just a good way to start out on the 10 by 10 by 10 grid. Okay, lucky for us, we can already see it. Now the problem is, I'm not sure if that went up above and it has 2 crossings or if it's just barely touching it. So I need to zoom in right there and take a look. I mean, that's obviously the vertex. Maybe we find the vertex first. If I go second, calculate. Now, take a look at that. See, that's the highest point. So now this vertex is the maximum point on this graph. So second, calculate. Now I want to do the maximum. So I got to type a number in over here, someplace left. So when I did zoom 6, these are counting by ones. 1, 2, 3, 4, 5, negative 5, negative 6, negative 7, somewhere around in there is definitely to the left. And then someplace over here, like negative 1, 1, 2, 3, I'll say 3. It's going to find the smallest point between there, which will, or the highest point between there. So there's the vertex, negative 3.1, and notice it's 0.06. It is above the x-axis. That does go across that x-axis, and it's going to have 2 answers. So there's our vertex, first of all, negative 3.1 and 0.0625. Now we got to find the zeros. So I want to zoom in on that so I can see what they are. So I'm going to hit the zoom and choose box. That lets me use my cursor. See, I'm pushing the arrow key. See that little thing floating around? Okay, I want that little thing to draw a box around the vertex so I can see it. So I put it about right there, and I'm going to hit enter. See, that made it turn into a little box. Now I can arrow around and it starts drawing a box. So it's going to zoom into that little box right there. As soon as I hit enter, that's where it's going to zoom. That's called zoom box. And look, now I can see them. There's one of the answers, and there's the other answer. If that doesn't look clear enough, you can always do a zoom box again and just zoom in on it again if you want. I mean, that would have been clear enough for me. But if we want to, just make sure you get around the zeros, because that's what we're really interested in. I'll lock it in right there. And I'll draw my zoom box over to here and let it zoom in between there. See, it just zoomed in more. It's more obvious that there actually are 2 zeros. So to find them, I want to go to calculate. Second, calculate the 0. It wants me to be to the left of this answer. Now, I don't have any more tick marks, but I do have the little bug. So you can just move the bug to the left. Get your bug to the left of this spot. Doesn't matter how far left, so I'm definitely to the left, hit enter. And now it wants it to be to the right of that spot, so I'm definitely to the right. So see, it marked those 2 spots. It'll search between there and find that one. So there's one of the zeros, negative 325. And now I need this one over here, same thing. Second, calculate a 0. Be to the left, but don't be involved with this one. So I could hit enter right now. I'm definitely to the left of this one, but I think I'll just like to get a little bit closer. Okay, there I'm to the left, hit enter. Now it wants me to be to the right, so keep going. Now I'm to the right, and I don't need to guess because it's going to search between those two spots and find it. So it looks like -3 is the other one. Okay, and now the last one. Let's put that in. X squared minus 511x plus 65281. That's an upshift. It's going to be shifted really tall, I think. That's what I'm anticipating. Okay, zoom. I'm going to start out with my square, my standard 10 by 10 grid. Okay, so those numbers are so big it's not even on the 10 by 10 grid. So I am going to make my window go out. I'll go out to 100 by here. So I'll make it go to the hundreds by 10, and for the y-axis to the hundreds by 10. See if that finds it. Still not enough. And that could anticipate that. It's 65,000. It's probably way the heck out there. So now I'll make it go to the thousands, count by hundreds. So now it's looking all the way out to 1,000. Okay, there it is. So it doesn't look like I needed to go all the way sideways 1,000. Looks like, remember I counted by hundreds, 100, 200, 300. I probably could have gotten away with 400 to 400. So I think I'll do that. I think I'll go on the x-axis, -400 to +400. That'll just make it easier to see. So there it is. Same problem. I don't know if that's crossing the x-axis or not. Before I zoom box in there, I'll just find the vertex and see. Because if the vertex is above the x-axis, I don't need to search for them. I know it doesn't touch. So I'll do second, calculate the minimum. I want the smallest value of this picture. So I have to go to the left. Okay, I counted by, what did I count by again? 100. So that's 100, 200. So the left I'll put in 200. And for the right, I'll put in 300. So it's going to search between 200 and 300 and find the minimum value. So there's the vertex. Notice it's above the x-axis, so it's 255.5 at 0.75. So if I zoom in, I know that that's just barely going to miss. It's going to look like that because it's 0.75 up and it's pointing up, so it's not actually touching. So I already know there's going to be no zeros. But just to check, if I do a zoom box, I'm going to make my little cursor guy come down there and zoom in on it, and I will see that it is not. I'll lock it in right there, come across and come down so that I'll zoom box right in that and see. Okay, that's still not quite zoomed in enough to tell. I think I'll do another zoom box. Since I know what I'm looking for here, I'm going to keep going until I actually have my machine tell me. See, it's not touching. So there are no zeros on this one.